Okay, you have this amazing question that is to solve for the limit as x tends to the infinity of 1 over x to the power 1 over x. Here is a bit a complicated type of limit because you have rational fraction in both sides to the power it. Okay, by tautology, someone just say if you substitute directly infinity here, that will be 1 over infinity, or that to the power 1 over infinity, and that will be equal to 0 over to the power 0. Logically, this can turn to 1, okay? Meaning that the answer to this is exactly 1. But we have to prove it mathematically. So as solving it digitally and having the final answer. Let's get through it and let's solve it together. Okay, how can we solve it? We can take a short trick. We can say y is equal to what? 1 all over x, all that to the power 1 all over x. Okay, how can we simplify this inside here? How can you do it? We can have what? That will be equals to x to the minus 1 because 1 over x is as x to the minus 1 or to the power 1 over x. And from basic indices, we can just multiply here. And therefore, y will be equal to what? X to the power negative 1 over x. And that is what we have. Then our next step is to bring this negative 1 over x down. Okay, how can we do that? We can introduce a ln function, that is ln of y, that is on both sides, is equal to what? Ln of x to the power negative 1 over x. And basically that will be equal to what? Negative 1 over x ln of x. Therefore our final answer will be what? Ln y is equal to what? Negative ln x all over x. Okay, that's what we have. Now we want to have y back. How can you have y back? We introduce an exponent, as e to the ln y is equal to what? E to the negative ln x all over x. So as to substitute back the y in the initial equation of limit. Okay, here we have y is equal to what? E to the negative ln x all over x. Yeah, that's amazing. We reach a point and we can just substitute it back in the initial equation where we set y, because we have ln as x tends to infinity of what? Y. Yeah, that's what we had. Therefore we can substitute back. That will be equal to what? Limit as x tends to infinity of what are you having here? E to the negative ln x, e to the negative ln x all over x. Looking at this question, e is a constant because no matter what, infinity will not, or the value of x will not affect how e will function. Okay, we can just bring this limit inside and have what? Move to the next slide. That will be equals to e to the negative. We just put the negative outside because nothing will affect it. Negative limit as x tends to infinity of ln x all over x. And that's amazing. That's really amazing. We are left now to find the limit. Let's do it on the other side. So the limit as x tends to infinity of ln x all over x. Okay, looking at this question, if you look at this, the numerator, limit of x all over x, you see that this limit tends to infinity and this one tends to infinity as x is infinity. But if you try to find out the difference in them, x is greater than ln x. Okay, or ln x is less than x normally automatically, hence the limit of this will automatically be 0. Yeah, I know you guys not understanding what's really happening. Yeah, I know you're understanding. Let's do it just gently. Let's take a big value that is 1000. Limit of 1000 all over 1000. What's going to be the answer? Limit of 1000, I think that is 3. Okay, limit of 1000, that is 6.9 all over 1000. Okay, and you are seeing this 1000 is bigger than this. And if you continue moving to infinity at a point, this will be extremely large that we can't divide and we have a 0. Okay, we can also use the L'Hopital's rule. What's the L'Hopital's rule teaching? By dividing the numerator and divide the denominator, that is ln x all over that. If you differentiate ln x, that you are to have what? 1 over x And if you differentiate x, you are going to have 1. Therefore, our limit as x tends to infinity, that will be 1 over x, and automatically 1 over x as x tends to infinity is equals to 0. That is a final answer to this. Okay, then if you come back here and substitute our answer in here, we're going to be having what? E to the minus 0. And no matter what, minus 0 doesn't really exist, because minus 0 is the same thing as 0. That will be equals to e to the 0. And e to the 0 is finally equals to 1. Hence, if we come back to our initial point, erasing, everything will be equals to what? This is equals to 1. I know by logic you could have 1, but actually solving it basically using basic principle of mathematics. If you found this video adding some values to you, just subscribe to the channel. Goodbye.